Hey all! We got our Prusa CORE One assembly kit, and today we're going to assemble it. So cue the intro, and let's start with the project. So let's take a look what we have in this huge box. So first thing, some thank you note. I'm gonna put it aside, and then we have the receipt look-like thingy that you get with every Prusa printer or assembly kit that shows that everything is okay. For now, we're going to trust them. Of course, the famous Haribo gummy bears. And then we're going to get to the printer itself. We have the printer handbook, some USB with probably pre-sliced G-code files, and let's start to get everything out. So this is what seems to be a build set or something else. It says plexi set. Okay, so that's probably the plexi sheets for the side, the sidings of the printer. We have two PI sheets. One of them should be textured and regular PI. We're going to put that aside. We're probably not going to need them until the end of this video. And then we're going to start with all the actual parts. Oh wow, those are huge and heavy. Electronics, rods, electronics and chamber parts. Ooh. Oh my god, metal parts. Man, everything here is so big I can't even fit it in the frame. Motor kit. So I'm assuming those are all the stepper motors with the lid already pressed into them. That's what Prusa likes to do. Okay, some printed parts. More electronics. More metal parts. It just says part 2 out of 3. Core XY parts. And we'll have to take the box down, so we'll have more space. And metal parts, which are probably the metal enclosures. So let's move the camera so you guys can see everything. So looking at all of these parts, we have a lot of work to do. It's a little bit overwhelming, but Prusa has a very good guide online. And while I'm trying to assemble everything, I'll put the guide on screen so you guys can see it with me and see what I'm doing. So yeah, we have a lot of work. With what I see online, it's about 18 to 20 hours each, depends how fast you are. So let's see how long it will take us to do it. Let's start with the build.
Prusa CORE One, take me higher. Build my world, spark my fire. Extrude the night, shape the dawn. Prusa CORE One, let's carry on. Piece by piece I find the flow. A puzzle world I start to know. Gears in my hands, turning slow. Stepper motors hum a tune. Nozzles glow under the moon. Building dreams in this small room. Click, snap, twist, align. Each part falls into time. It's
So we're done with the building process of the printer. Now it took us about 14 or 15-ish hours of print time. So that's why when I was recording this video at the beginning, I thought it's going to be one video, but it's kind of impossible to make it as one video. So we're going to separate the build portion to the actual usage review-ish and my thoughts about the printer. So let's talk about the printer itself. The external dimensions of the printers are 415 millimeters by 444 by 555 millimeters of the entire printer. It weighs about 23 kilograms, depends on what accessories you have, of course. So it's kind of heavy. It's not as easiest to move it around, but it's not a bad thing. The build volume of the printer is about 250 by 220 by 270 millimeters. And the nozzle max temperature is going to be 290 degrees Celsius. By the heat bed max temperature is 120 degrees. The max chamber temperature of the entire chamber of the printer by Prusa is 55 degrees Celsius. And I'm saying it's with the biggest asterisk ever because there are some problems and we'll talk about it in depth when we get to it. Moving on, the extruder itself is the same one that as the Mark IV, and it's a great design. I really love it. You do have two main changes. Add an extruder, first of all, is the cooling fan. Now it's mounted on the back, which was one of the main thing we talk about the Mark IV's upgrade is that fan at the front, the huge fan works great, but you can't see the nozzle. And it's very hard to see if the nozzle is dirty, if you have a problem with the print, with the first layer. So now it's on the back, which is great. And the second thing is if you look at the actual extruder gears inside of the extruder, we see that they have some holes in them that I'm assuming they add them for weight saving, which is pretty cool to see it. Now the bed leveling of the printer is going to be done with the nozzle. There is a load cell in the nozzle. We do also have two filament sensors, one on the extruder and one at the filament storage area. We do also have a door sensor that will pause the print if you open the door, but if you don't like that feature, that is something you can turn off in the settings, and I did that for this entire video, so I'll be able to open the door and actually show you guys what happens in the printer. Now let's talk about add-ons. So this printer, and like other printers that Prusa make, we have several add-ons. Now, one of them we're not going to talk about at all in this video, and that's the MMU unit or the next-gen MMU unit, which is going to have the tool changer. We're not going to talk about that. We're going to have hopefully a separate video talking about that system when it will be released and while I have my hands on it. But for now, what are the add-ons we can buy? First thing is a camera. This printer does not come stock with a camera. I don't have that camera because I'm not using Prusa Connect and their camera system. Recently, they released some updates to make that camera work better. But overall, if you're trying to see your printer from anywhere outside of your network, the frame rates you're going to get is about one frame every 30 seconds. And for me, it's not something I want. And if I want to actually monitor my printers, I won't be able to do it with one frame every 30 seconds or so. Now, with the current update, the cameras now actually record in, I don't know, 30 frames per second or something like that. But only if you are inside your network. So still, it's not something that's going to work for me, but out of the box, it's something you can buy. It will magnetize to the enclosure, and it will be very easy to just use their app to tune it and connect it to Prusa Connect. Another add-on that we have is the active filtration system, which we don't have it right now for this video, but we do have it. We purchased it, it's coming, and that will be something that I would like to add to this printer because I'm going to mainly use ASA, ABS, and above that filament, so PC and nylon. So that will be something that I will add on, and we'll talk about it in the upgrade video. We're going to have a video of me just upgrading the printer. So now we're going to go back and talk about the heated chamber and some problems or caveats we have with it. So the wording for it on Prusa's website is that it is an active temperature controlled chamber. Now that's not wrong, but the use of the word active might be a little bit misleading. When we talk about active temperature or active heating environment, we mean that there is a fan and a heater that will actually circulate the air and will heat the entire chamber equally. So now let's see what's going on with the Prusa CORE One. So the Prusa CORE One uses two large fans at the top of the printer. And the temperature sensor for this chamber is located on the highest most center portion of the printer. Now, because this printer uses the heat bed, which is not an active way of heating the chamber, the bed will get hot, and the hot air is going to radiate from the build plate and heat everything above the bed. And what it will cause is basically like two different chambers. We're going to have the chamber above the heat bed that's going to be temperature control-ish, and then we're going to have the portion below the print bed that's going to be much cooler. Now, I don't have a calibrated equipment to actually test it and show you the delta between this temperature, but if I can feel it when I put my hand in it, then it's large enough to be a problem. So why is it even a problem? The bed, the way that it works, it's going to go down in the z-axis while it's printing. And while it's printing, it's going to expose your ASA or ABS or more complex material into cooler air all the time. Since the hot air is going to rise up, the sensor will continue seeing those 55 degrees, but those 55 degrees Celsius are not going to be equal all around our chamber. So while this bed starts going down, we're going to start to get warping in the prints. And oh boy, it will warp. So while trying to print ABS, ASA, that are not very small parts that the bed actually go down into the cold area, we did saw a lot of warping. Now, we did solve it with adding carbon fiber to our filament. So while printing with carbon fiber ASA or carbon fiber ABS, those fibers help fight a little bit of this warping, and we got perfect prints. And they were actually really nice, and we're going to talk about it at the print quality portion of this video. But I do think that having an actual active heater to this chamber will take this printer, which by the way is very good, but it will take it a notch up. I do think Prusa missed with not having an active heated chamber for this printer, especially when we look at the other options in the market, the Bamboo Lab and other companies, that all of them actually releasing their new printers with an active heating element inside of the printer. But that was something we'll have to fix ourselves, and we'll have a dedicated video about it of trying to make this heated chamber active. Now let's go and talk about the actual printing. So while recording this video, Prusa released what they call the software fix or the VFA fix, call it however you want. So this printer now is running 6.3.5 alpha firmware, and the slicer we're using is 2.9.3, and that's the beta version with all the new profiles. So first, let's talk about our 3 new profiles and how they differ from one another. Now we have structural, balanced, and speed profile. Structural is going to be the same one we have before. It's going to give us a little bit lower speeds. It's going to be the strongest part we can get, but we're going to have a lot of VFAs. The balance profile is going to have less structural integrity compared to the structural profile, but we're going to have, at least what Prusa claims, parts with less VFA, and I'm saying like that because they're saying that they solved the VFA issue, but let's call it for now less VFA. And the last profile is going to be the speed profile, which would give us less strong parts, but should give us much faster prints and with the same-ish VFA quality. Now, first of all, let's look about the difference in the profiles actually in the slicers. While comparing the two profiles side by side speed-wise in the slicer, we see that the balance actually print the external walls much faster than the internal walls, and the speed profile do the opposite and prints the outer walls slower than the inner walls. Now let's take a look on an actual print examples and see the difference between them. Now the first thing I would like to start talking about is those two benches. One of them was printed with the balance profile while the other was printed in the speed profile. Now those two parts being small parts, the time difference between these two profiles was about a couple of minutes. So while looking at the actual print, it looks pretty good, but we still can see VFAs. And I'm expecting both of these parts to be very similar because of the time that the slicer said it's going to take them to print. So let's take a look about the speed profile. And we can still see the speed profile have the same VFAs, and it looks pretty much the same. I would say this is a very good quality benchy, but both of them have VFAs, and you guys will be the judge about that, if you think Prusa solved the VFAs issue or not. Now let's take a look on a larger print, and first of all, let's talk about why we even chose that print. This is one of my phone charger cases, and I chose this print because it has a few main features that will allow us to see some VFAs or some problems that can happen in a print. So first of all, on this connection between the base and the top portion will have different speed, which here we already see there are different colors, and you can see the actual sign when the speed changes. We also have a very long lines that the printer can accelerate to the top speed it can go, and then places that it will have to decelerate and will change direction, and that will allow us to actually see and get those marks that we see here. So first of all, let's talk about what it is. This was printed with the balanced profile. So with the balanced profile, well, looking at it like that, we do have some VFAs, but extremely little. It's very difficult to see them, and if we have something, it's fairly uniform. So to be honest, I'm very pleased with this print. But printing that fast and going to those speeds where the points of the printer has to slow down to actually change how it prints and change directions, we start to see all of these artifacts in this corner, and that's the change of the colors. Now between the balance and the speed profile, which the speed profile prints a little bit faster, those marks are going to be much noticeable because the printer will need a longer portion of the print to actually start decelerating and get to that speed he needs to be on this point to change direction. Now let's look at the back. The back of the print looks fairly good with some VFAs, but overall very acceptable, and the quality looks pretty great. Now let's compare that to the speed profile. Now the speed profile still suffer from the same problem here, which a lot of the other prints will have, with different speeds and different shrinkage between the base with the infill and the actual top of the print. But here it's noticeably longer, and you can sear much better without even trying, because the printer here needs to decelerate over a larger area. Looking at the back, we can see a little bit more VFAs and ringing over here, but overall still very good print. Now between these two profiles, you guys will decide if you'll prefer the time saving and add in more and more of these artifacts, or you prefer something that will print longer and have less artifacts. And printing longer, let's look at the structural profile. This profile, in my opinion, looks much better, but also worse at the same time. So let's look at those lines. Everything here was printed basically at the same speed, so we don't have hard deceleration and acceleration, so we don't have those artifacts. But while we start looking at this print, we're going to start seeing more and more of these VFAs. And as Prusa said in their article, the balance profile will still suffer from VFAs, and they can't fix it. Going and looking at the back of this print, and that's where, boy oh boy, mother of all VFAs, that's where you can actually start to see the problem that the Core One had at the beginning and still suffer from, severe VFAs. And I'm saying it as the Core One, but every Core XY printer suffer from VFAs, and probably from the same level or even worse. So if you grab any Bambu Lab X1C and one of those printers that they have, they're also going to suffer from VFAs. It's just how it is with the Core XY system. Now, there is ways to solve it, but Prusa chose not to do it with this printer. So I do think that even with the VFAs and all these artifacts, since they are very consistent, the entire print, I still think this print looks better, even though it has more artifacts, just because I don't have these weird marks in here. And just for another example, ASA carbon fiber prints. The carbon fiber itself kind of hides all the VFAs. And look at this print. This benchy looks amazing. So this is again ASA carbon fiber, and I'm just showing to you guys that thing because I really think that adding carbon fibers to some of these more complex materials might help us with making the print looks much better. So yeah, that's an ASA carbon fiber. And look at this print. You can barely see the layer lines. Moving on. For conclusion, I really like this printer, and I'm definitely going to recommend it for people. We talked about some of the specs and the good parts. We also talked about some of the problems with the printer. But I think all of these problems are very minor problems and definitely can be solvable, especially when we're talking about the printing with more complex materials that not everyone is going to do, and some of the people that buy this printer just would like to print PLA and multicolor prints, and for it this printer is perfect. Now, with adding and modifying this printer with an actual active chamber heated control, I think this printer is going to be amazing to print any other materials. Now, I know some of you might not going to experience the same problems that I had, because every one of us print in a different climate, in different environment, in different moisture in the air. And some of you guys might have a huge success with printing with ASA. But I do have to say that my opinions and experiences are mine. So they are correlates to my environment and where I live, with moisture in the air and the temperature, as I said. So take that as it is. On our next videos, we're going to add stuff to the printer, upgrade it, add the active filtration system, and I'm going to design a way to actually heat the entire chamber, actively heat the chamber, and make this printer better. So stay tuned for the next video. That's going to be us upgrading some stuff, and we're also going to have a full series of me building the printer. So guys, I really hope you liked this video. It was a lot of work. If you like the video, you know what to do. Hope you guys will also subscribe to us, and hey, we'll see you on the next video.